Hello everyone, my name is Kyle and I am the lead developer and creator of Kanairi. Today we're going to go over the math behind Kanairi. This is for those of you out there that tend to be a little bit more on the nerdy side like me and want to know the inner workings of Kanairi and what's kind of under the hood. This math that I'm going to show you here, Kanairi does about 100 times a second, so it's very, very fast. The example that we're going to do is riding a Harley down a freeway at about 65 miles an hour and having an accident. Unfortunately, this happens all the time. We never want it to happen, but it does, and this math shows why it's important to have a device like Kanairi on you when an accident like that does occur. So we need to know three things. We need to know total weight, we need to know velocity or how fast you're traveling, and we also need to know the time of the accident or the initial impact. Now, accidents or collisions can last multiple seconds, but what we actually want to know is the initial impact. How long does that last? And typically it's between a half a second to a second. It can even be less than half a second if you're traveling really fast. So for this demonstration, we're going to do a bike weight of 600 pounds, which is an average bike weight for a Harley. So 600 pounds actually equals 272.15 kilograms. Now the next thing we need to know is the rider weight, because we need to get a total weight. So the rider weight we're going to say is 180 pounds. And in kilograms, that is 81.64 kilograms. Okay, so now we're halfway there. That makes the total weight equal to 353.79 kilograms. Okay, so the next thing we need to do is the velocity, or how fast you're traveling. The velocity, we're going to say we are on a freeway, so the velocity is going to be 65 miles per hour or 104 kilometers per hour. And the last thing we need to know is the time of impact. So we're going to say that was a half a second, or 0.5 seconds. Okay, so the first thing we need to do is convert the kilometers per hour to meters per second so we can actually work with it. So let's do that really quick. Okay, so if we are traveling 104 kilometers an hour or 65 miles an hour, we actually are clipping along at 28.888 meters per second. Okay, so the last formula that we need is 2 times by mass times by velocity divided by time of impact. Now we have all that right here, so we just need to plug it in. And what we get is the force of the crash equals 40,869.82 newtons. Now, for all of you physics nerds out there, you will remember newtons. What we need to do is actually convert the total weight to newtons now using standard gravity. So the total weight was 353.79 kilograms times by standard gravity, which is 9.8, equals 3,467.14 newtons. Now all we need to do to get the g-force, which is what we are concerned with, is we need to do 40,869.82 divided by 3,467.14, and these are both newtons. What this gives us is 11.787 G's. Now that is a lot of G's. The Apollo 16 re-entry, if you do remember that, was actually 7.19 Gs. So you are pushing way over the Apollo re-entry. The average human can withstand between 4 to 6 Gs for a brief amount of time. Anything over 4 to 6, you actually start to black out, and that's when you have brain damage. So this is a ton of Gs for someone to encounter at any one time, actually in a half a second. That is the math behind Kanairi and why it's important to carry it.